minute before we end this year. So we're going to talk about exponential and logarithmic functions and equations. You've seen some of this stuff in your integrated 3 studies. So we're going to take a quick look at that again. So we're going to start with recalling that an exponential function has the form y equals b to the x. So a couple of things about b. B has to be greater than 1. Otherwise, that will not be an exponential function. B is called the base of the exponential. X is an exponent. That's your independent variable. That's your input. And so we can use properties of exponents that you've studied before. You've studied before in a previous math course to help solve equations if, and this is the important part, we can rewrite so the exponentials have a common base. And so it's going to be really important that we know common powers of 2, 3, 4, 5. And so what I mean by that is 2 to the first is 2, 2 squared is 4, 2 to the third is 8, and so on. You should know the first few for each of these values. All right. So if we look at example 1, we have 8 to the x equals 16 to the x minus 1. And you should recognize that 8 and 16 are both powers of 2. All right, so what we're going to do is we're going to rewrite the base as a power of 2. Okay, so I'm going to take the 8, I'm going to replace it with 2 to the third to the x power. 16 is the same as 2 to the fourth. So I rewrite 16 as 2 to the fourth, and that's going to be raised to the x minus 1 power. Now, our exponent rules tell us that if I have a power to a power, right, I have 2 to the third to the x, I can rewrite that using multiplication of my exponents. So 2 to the 3x is equal to 2 to the 4 times x minus 1. Again, I'm multiplying my exponents here. Once we get it in this form, once we get a base of 2 equals a base of 2 to a power, we can pretty much just ignore that base. So for this to be true, it must then be true that 3x is equal to 4 times x minus 1. And so we took this problem, we rewrite it. Once we get a base to a power is equal to the same base to a power, we can just set our exponents equal to each other. So we set our exponents equal to each other. All right, so if we solve this, we distribute 4x minus 4 minus x equals negative 4, so x equals 4. All right, so if I plug in a 4 here, 8 to the fourth is equal to 16 to the third. Okay. All right, so now what I would want you to do is pause the video, try these 3 on your own, and then come back and see how you do. All right, hopefully you gave this a shot. All right, so 3 to the 2x plus 3 equals 81. 81 is a common power of 3. So 3 to the 2x plus 3 is equal to 81 is the same as 3 to the fourth. We have a common base. So this implies that 2x plus 3 must equal 4. 2x equals 1, and so x equals 1/2. And so there is our answer. Okay. Number 2, a little bit more challenging. So 25 to the x plus 2 over 1 over 125 to the x. And so these are both have a base of 5. So 25 is the same as 5 squared. 1 over 125, well, 125 is 5 to the third power, but since it's 1 over, that's going to be 5 to the negative 3 raised to the x. And so now I have 5 to the 2x plus 2 is equal to 5 to the negative 3x. Again, here I'm using my exponent rules. So 2 x plus 2, the quantity, is equal to negative 3x. 2x plus 4 is equal to negative 3x. Negative 5x is equal to 4. I subtracted 2x to this side and then rewrote it. So x is equal to negative 4/5. All right, last but not least, 1/2 to the 3x is equal to 64. So I'm going to rewrite these using powers of 2. So 1/2, again, is similar to 1 over 125. I'm going to rewrite that as 2 to the negative 1, 3 to the x. 64 is the same as 2 to the 6th power. And so we get 2 to the negative 3x equals 2 to the 6. Negative 3x equals 6. And so x equals 2. All right, and so if we can rewrite our exponentials so that they have the same base, we then use exponent rules, power of a power. And since the bases are now the same, we know our exponents must be equivalent to each other. And so that's the equation you're going to solve.